Let us discuss some of the MCQs related to chemical kinetics and general principles and techniques in the extraction of the elements. Now, first question, this is related to the kinetics. A first order reaction is carried out starting with the 10 mole per liter of the reactant, and it is 40% it is complete in 50 minutes. If the same reaction is carried out with an initial concentration of 5 mole per dm cube, so instead of 10 mole, they have taken 5 mole per dm cube, the percentage of reaction that is completed in 50 minutes is. Now we have to remember that the first order reaction is independent of how much amount you take initially. So if it is 40% gets completed in 50 minutes, for the 5 mole per liter also it will be 40% completed in 50 minutes. Next question is the rate of the first order reaction is 0.69 into 10 raised to minus 2 per minute, and its initial concentration is given. We have to find the half-life period. Now the rate of reaction, since it is first order, is equals to K into the concentration. The rate is given is 0.69 into 10 raised to minus 2. Instead of K, I can write it as K is nothing but T half. K relation 0.693 upon T half. So the T half, instead of K, we can write it as 0.693 upon T half into concentration, which is given in 0.5. So T half is equals to 0.693 into 0.5 upon 0.69 into 10 raised to minus 2. So that is 50 minutes, and 50 minutes is nothing but 3000 seconds. The experimental data for the reaction given twice of NO plus Cl2 is giving twice of NOCl. The data is given. We have to find out the overall order of the reaction. This equation we can just solve by taking the rate of reaction is K into the concentration of NO. With respect to that, let's say assume it as X, and with respect to Cl2, let us assume it as Y. So now in this case, if you talk about the rate of reaction over here, for the first equation, we can write the rate of reaction is 2.40 into 10 raised to minus 4 is equals to K into 0.020 raised to X into 0.010 raised to Y. The next equation is 2.16 into 10 raised to minus 3 is equals to K into 0.020 raised to X and 0.030 raised to Y. Then it is 4.32 into 10 raised to minus 3 into K, 0.040 raised to X and 0.030 raised to Y. So if we can see, when we change the concentration of Cl2, the rate almost remains the same. So it is, I can say it is Cl2. If you just do this will comes out to be around 1, and when you will multiply this with the NO2, so NO, if you see the concentration is double, the rate is also double, so this is twice. So rate is twice, order of reaction with respect to NO is 2 and Cl2 is 1, so overall order has to be 3. The catalytic decomposition of H2O2 was studied, and the titrating sample with the 0.1 normal KMnO4 solution at the various time intervals has been given. So you can see as the increase in the time, the concentration of H2O2 is found to decrease. The graphs were plotted with the log of H2O2 versus the T. If this is a first order reaction, for the first order reaction, the log of the concentration of A is equals to minus KT upon 2.303 plus log of concentration of A0. And here we are expecting the graph should be decreasing with the slope on the y-axis and the negative slope. And this kind of graph is option C. The activation energies of the two reactions E1 and E2, where E1 is greater than E2, if the temperature of the system is increased from T1 to T2, the rate constant of the reaction changes for the K1, it's K1 dash, and K2, it's K2 dash, the second reaction. What are the expressions which are correct? If I talk about a log of K1 dash upon K1 is equals to E1 upon 2.303 R into T2 minus T1 upon T1 into T2. Similarly, log of K2 dash upon K2 will be equals to E2 upon 2.303 R into T2 minus T1 upon T1 into T2. Since E1 is greater than E2, then log of K1 dash upon K1 upon log of K2 dash upon K2 will be greater than 1. Therefore, log of K1 dash upon K1 will be greater than log of K2 dash upon K2. So we have option B for this. Next question, this is based on the isolation of the elements. They consider the following reactions at 1000 degrees Celsius. Zinc is getting oxidized to ZnO, delta G is minus 360, and carbon is getting oxidized, it's minus 460 at 1000. We have to select a correct statement. Zinc can be oxidized by the carbon monoxide. If we can see carbon monoxide, zinc can be oxidized, and carbon monoxide reduction, if we find for the carbon monoxide reduction, for the formation it is minus 460. So definitely if we use the carbon monoxide as a reducing agent, for that delta G will be plus 460. And if it is delta G is positive, the reaction will become non-spontaneous. So A is not possible. Option B, zinc oxide can be reduced by graphite. That means we are talking with respect to the same two reaction. Both these reactions in the zinc oxide, if we are reducing, the delta G of that will be positive. So it is non-spontaneous, but here it is minus 460. So graphite can reduce the zinc oxide. Both the statement A and B are true. That's not right. Both the statement A and B are false. So option is B. Which of the following statement about the advantage of this roasting of the sulfide ore before the reduction is not true? The delta G of the sulfide is greater than that of those of the CS2 and H2S. Definitely the sulfide, metal sulfides are very difficult to reduce. Metal sulfides, when they are reduced, they get converted. If I am using carbon as a reducing agent, then they will give me the CS2. And if I use the hydrogen as a reducing agent, then H2S. But both this reaction have their delta G that is positive. So delta G of the sulfides are greater for that of CS2 and H2S. They are positive. So definitely this is right. Delta G is negative for the roasting of sulfide ores into oxide. Definitely sulfides can be converted into oxide easily, and delta G is negative for that. That's why option B is also right. Option C, the roasting of the sulfide of oxide is thermodynamically feasible. Roasting of sulfide to oxide is thermodynamically feasible because delta G is negative. So option C is also right. Carbon and hydrogen are the suitable reducing agent for the metal sulfides. No, they are not. That's why their delta G is positive. Hence, this statement is not true. Next question is, according to the Ellingham's diagram, the oxidation reaction of the carbon to carbon monoxide may be used to reduce the which of the following oxide at the lowest temperature. In Ellingham's diagram, you will find aluminium, magnesium and zinc at the bottom of the Ellingham's diagram. That is indicating these metal oxides are highly stable. Hence, they require higher temperature for their reduction. So, our option is copper oxide, Cu2O. The common depressant which is used in the froth flotation process for the separation of zinc sulfide and PBS. When we talk about the froth flotation process, if we carry out for the zinc sulfide and PBS mixture as it is, both these form the froth and they will come into the froth layer. But if we add a depressant, for example like sodium cyanide, the zinc is having affinity for the cyanide ions, and that's why zinc sulfide will stay in the aqueous solution while only PBS will go into froth. So we can carry out the purification of these ores as well as the separation of PBS from the zinc sulfide. Hence the depression used in this process is option C, sodium cyanide. In the view of sign of delta G0 for the following reaction, we can see for the first reaction the delta G is less than 0, so that is negative. So this reaction is spontaneous. If the reaction is spontaneous, the product is stable. That means Pb is plus 2 stable, is stable in stable in plus 2 state. If you talk about the next one, SnO2 is giving with the Sn giving SnO. For this, delta G is positive, so this is non-spontaneous. That means Sn is more stable in its plus 4 state. That is, reactant is more stable. So which oxidation state are more characteristic for the lead and tin? So for the lead we have plus 2 and for the tin we have plus 4. That's why option is C. Let us discuss some of the MCQs of the coordination compounds. The complex CONH3 plus is the inner orbit complex, whereas the COF6 is the outer orbit complex. The number of unpaired electrons in the two complexes we are to find. Now when I'm talking about the cobalt, it's atomic number 27. The configuration is argon 3d74s2. In both these complexes, the cobalt is present in its plus 3 oxidation state. So it should be 3d6. Now when you draw this 3d6, 4s is empty and 4p is also empty. Now here the first complex is an inner orbit complex. That means it is D2sp3 hybridization. So 2 of this electron will shift here. As 2 electron will shift here, there will be 0 unpaired electron. But if it is outer orbit complex, this unpaired electron will keep it as it is. That's why there will be 4 unpaired electrons. That's why the number of electrons are 0 and 4. The correct IUPAC name of the compound K3Al-C2O4 Now this particular complex is an anionic complex. So we'll write the name of the cation first, that is potassium. This is oxalate, but the name of the ligand should end up with the term O. So this is trioxalato. Aluminium should end up with the term aluminate 3. So it is potassium trioxalato aluminate 3. So our option is option A. Amongst NiCO4, NiCN4 and NiCl4, we have to find which are the diamagnetic and paramagnetic. When we talk about the nickel, its atomic number is 28. So it's argon 3d8-4s2. If you talk about this particular complex in which the nickel is present in its plus 2 oxidation state, so it will be only 3d8. So in case of 3d8 configuration, 2, 3, 4, 5, 6. So there is 3d8, 4s is empty and 4p is empty. Now these are all tetrahedral complexes. Now when we talk about tetrahedral complexes, cyanide is strong field ligand. Strong field means what? The gap is very, the splitting pattern is gap is very large. So it will be having dsp2 hybridization. For dsp2, it has to make one orbital empty. So it will make that empty. So there will be 0 unpaired electron in case of nickel cyanide. That's why in case of nickel cyanide, if it is 0 magnetic, then this 0 unpaired electron, this is diamagnetic in nature. Similarly, in NiCO4, nickel will be in sp3 hybridization. If it is sp3 hybridization, then it will be having 2 unpaired electron, and NiCl4 is also sp3 hybridization. That's why it is also 2 unpaired electrons. So NiCl4 and in case of the NiCN4, both these complexes are paramagnetic, while the CN4 complex is the diamagnetic in nature. So Cl4 is paramagnetic, while CO4, that is cobalt, this is dsp2, sorry. So both these are diamagnetic and Cl4 is the paramagnetic in nature. That's why for question number 3, option is C. CO4 and CN4 are diamagnetic and Cl4 is paramagnetic in nature. The number of geometrical isomers possible for the square planar complex MABCD is. If I have MABCD, the arrangement surrounding this square planar will be like this. We can have the other arrangement like MAB. I'm just changing D and C like this. Another arrangement MA. I'm just changing. This is C with B. So there are 3 geometrical isomerism possible. So our option is B. The coordination number and oxidation state of chromium in K3Cr2O4 thrice. Here the coordination number, this is a bidentate ligand, that's why 3 into 2. So the coordination number is 6 and you don't have to think further. It's option A. Oxidation state of chromium will be +3 in this. The increasing order of molar conductivity for the complexes we have to find. But before that, we'll find a number of ions which are formed. So 1 plus 1, that will be 2 ions. Here there will be 1 ion because it's a coordinate complex, it won't dissociate. Here will be 3 plus 2, there will be 5. And here 2 plus 1, there will be 3. Now in this case, if we have to find the molar conductivity, it will be lowest for the 2. Then it will be for 1, then it will be for 4 and highest for the 5. Hence our option is B. Question number 7. Which of the following pairs contains only tetrahedral complexes? We have to find where the hybridization is sp3. Now since chlorine is a weak field ligand, it's sp3 hybridization we are expecting. Nickel with the cyanide ligand, it's dsp2 hybridization. Zinc again with the chlorine, so this is sp3, this is also sp3, this is sp3 but this is dsp2. Ammonia and strong field ligand, so both we are expecting dsp2. Whenever it is dsp2 hybridization, it's a square planar. We have only one option, that is option B, where we have both the complexes sp3, that's why tetrahedral complexes. Which of the following considered to be anti-cancer species? Anti-cancer species is the cisplatin, where the platinum having 2 ammonia and 2 chlorine group arranged in a cis pattern. Hence option is B. For the given complex, that is COCl2EN NH3 twice, the number of geometrical isomers, number of optical isomers, and the total number of isomers of all the type possible we have to find. Now in this case, if I talk about geometrical isomers, that is of cis and trans type, in this case we have cobalt attached to the twice of chlorine and twice of ammonia, and that is En. In this case we can have 2 geometrical isomers, cis and trans. This is coordination number 6. So we can attach chlorine like this, then En, that is ethylene diamine, will be like this, and ammonia will be like this. So it's kind of like a cis, or we can attach chlorine like this, and this is trans. So 2 geometrical isomers. Out of this, if I talk about, this is cis and this is trans, the optical isomers will be 2 for this particular isomer, that is cis will show the optical isomers, so 2 optical isomers, and the total number of isomers, that is 2 geometrical and 2 optical, so there will be total 4. Hence for the question 9, our option is A. Which of the following complex formed by the Cu2 plus ion is the most stable? Most stable complexes are formed by the particular ions where the base is very strong. Here I'm just making a correction, this has to be cyanide because it's a cyanide complex. Now in this case, ammonia, cyanide, En and water, the most basic is a cyanide having the highest K constant we can see over here. Hence our option is B. The crystal field stabilization energy for the high spin D4 complex. Now if I talk about D4 complex, we have 4 unpaired electrons. Now when this will split into 2 groups, it's a high spin. High spin, that means the gap is very large. Gap is very small, so electron will prefer to go in higher shell. So if I talk about here, it's 0.4 decrease and 0.6 increase. The decrease is because of 3 electrons, so 3 into minus 0.4 plus 1 electron into increase 0.6. So that is equals to minus 1.2 plus 0.6, so that is equals to minus 0.6. So our option is option B. Let us discuss some MCQs of halogen derivatives of alkanes and arene and alcohol phenol ethers. Here the question number 1 is 1 phenyl 2-chloropropane when on treatment with the alcoholic KOH. So if it is propane 1, 2, 3, it's 2-chloro and one phenyl group. So this is the structure. This is on treatment with KOH, but this is alcoholic. Alcoholic KOH causes the elimination of chlorine from this carbon and hydrogen from any one of this. So we're expected to get double bond at this position or at this position. But according to the Sedgwick rule, we get the alkene with the more substitution, and hence we are expecting the hydrogen should be removed from this carbon, giving us formation of this particular compound. So this is 1, 2, 3. So we'll call it as 1-phenyl propene. So our option is A. In the reaction CH3CH-Br, if I treat this with the alcoholic KOH, the Br will be lost from here and H will be lost from here. I'll get CH2 double bond CH CH3. This is on treatment with HBr in presence of peroxide, which takes place according to the anti-Markovnikov's rule. So Br will go to the terminal carbon and we'll get CH2Br CH2 CH3. This is further on, this is our X compound, this is our Y compound, and further on treatment with NaI. This is Finkelstein reaction where bromine will be replaced by the iodine. So our product for the reaction is option A. The propyl benzene reacts with the bromine. Now if we talk about propyl benzene, this is propyl benzene. When on treatment with the bromine in presence of light and heat, this is the substitution reaction, and the substitution reaction will occur at the aliphatic carbon more compared to the aromatic. But now we have, this is primary, secondary and tertiary. The tertiary carbon over here is more reactive, so bromination will take place at tertiary carbon over here. Hence our option is D. The correct order of reactivity of the following compounds in SN1 reaction. As we have discussed, SN1 reaction is dependent on the stability of carbocation. Now if you can see, this is secondary carbocation, this is tertiary, tertiary, tertiary. These are the tertiary carbocation they will be creating. So SN1 is more stable for the tertiary, but we have 3 halogen to be compared. Now the one which can be broken very easily is the iodide. So iodide, fourth will have highest reactivity, then third, then 2, and the least is for the 1. Hence our option is A. Question number 5. Arrange the following in the increasing order of their densities we have to find. Now if I talk about density wise, amongst all of them, the benzene will be having lowest density. There is no substitution on the benzene. Then we can see there is chloro substitution, here also chloro, and there is bromine and chloro. So as the atomic numbers, atomic masses goes on increasing, the density will also go on increasing. Highest will be for 4, then 3, then 2, and the least is for 1. Hence our option is option E. What is A in the following reaction we have to find? So if the HCl is added across this, there will be a simple reaction according to the Markovnikov's rule, where the chlorine will go to the carbon having the lowest number of hydrogen atom. So we are expecting option C. Which of the following carbon atom present in the molecule gives are below are asymmetric in nature? Asymmetric are those which are attached to the 4 different carbon or a group, 4 different atoms or the groups. So in this case, if we talk about A, it's double bonded sp2, so this is not a chiral. This is attached to 4 different groups. Yes, B is the chiral, C is also chiral, but D is not. Hence our option is B. Question number 8. Reagents for the following conversion. We can see there is a dibromo compound which has been converted into alkene. So dibromo compound, if you allow this to react with alcoholic KOH, so what will happen? This is kind of CH2, CH2, Br, Br. If you allow this to react with alcoholic KOH, let's say Br from this is lost, then H from this will be lost. So we'll get CH2 double bond CH, Br. But to create a triple bond, we cannot use only alcoholic KOH. We need to use a very strong reagent So we have to go for NaNH2, a strong base, because the second removal of HBr is very difficult. So when you'll remove the second HBr, so Br from here and H from here, so we'll get CH triple bond CH. So our answer is alcoholic KOH followed by the NaNH2. Hence our option is D. Which of the following shows the SN1 reaction? Again, it's a SN1. So if it is SN1, the tertiary carbocation are more stable. If you talk about this is directly attached to the sp2 hybridized carbon, so it is not stable carbocation at all. This is a chlorine attached to the tertiary carbon. This chlorine is attached to primary, and this bromine is attached to the secondary carbon. So out of this, the one is more stable is a tertiary, and hence option B will undergo the SN1 reaction more readily. In SN2 substitution reaction of the following type, which of the following has the highest reactivity? If it is SN2, we just find the less is a bulkier halide that will give you the more faster reaction. This is primary, this is primary, this is primary, and this is also primary. But if you look at the less bulkier one is option C, and hence our option is C, which can give us the more reactivity for this reaction. The bottles containing C6H5I and C6H5CH2I lost their original labels, and now they have been labeled as A and they have labeled as B. Now while testing, they have been taken in the different test tube and boiled with NaOH solution. The end solution in each test tube was made acidic with the dilute HNO3 and AgNO3 solution, and added the substance B gave the yellow precipitate. So this is giving the yellow precipitate. So we have to find out which of the solution are present here. So if I talk about the aqueous NaOH solution and all these reactions, definitely these are all reactions with containing this C6H5CH2I, because C6H5CH2I is an aliphatic iodide. If you allow this to react with NaOH, if you boil it with the NaOH solution, this will turn to C6H5CH2OH. And the end solution of each test tube was made acidic, and which was diluted with the AgNO3 solution was added to that, and the substance B gave the yellow precipitate. So this can give us the yellow precipitate, that is the benzyl alcohol, which is on treatment with the AgNO3, can give us the yellow precipitate, and hence we are expecting for this reaction the A should be C6H5 iodide, because no reaction will occur with this, but B will only give you this reaction. So our option is B. What would be the product formed when the 2-bromo 2-chloro-cyclobutane, this is cyclobutane, then it is 1-bromo and 3-chloro-cyclobutane on treatment with metallic sodium. Metallic sodium, it's kind of like a Wurtz reaction. So halogen from this and this will be lost, and the bond will be formed between these two carbon with the one NaCl molecule and one NABr. So it's a Wurtz reaction and giving the product D. Which of the following is the most easily dehydrated? Now in the dehydration reactions, we have to always remember the tertiary alcohols are more reactive than secondary and then primary. This is primary alcohol. If you find this is primary alcohol again. This is tertiary and this is secondary. So out of this, the option C can be dehydrated very easily. In the following reaction, this is MgBr. If you oxidize this, you will get OMgBr, followed by the hydrolysis will give us formation of the phenol. So our option is option A. In the following reaction, if you allow this to react with H2CrO4, this is kind of like an oxidizing agent. If you allow this to react with oxidizing agent, we will expect to get a ketone, because this is a secondary alcohol. Now if I allow this further to react with the Grignard reagent, then this is positive, this is negative and this is positive. So this will get MgBr. So we'll get CH3 COMGBr, and this will get the propyl group CH2, CH2, CH3. This CH2, CH3 as it is, followed by the hydrolysis will create OH here. So the alcohol will be formed. Hence our option is option A. In the reaction, this is benzene ring MgBr. This is on treatment with the epoxide. So it's MgBr. This is CH2, CH2O. This ring will break here. So oxygen will get the MgBr and CH2 will get the benzene ring. So CH2 will get the benzene ring, CH2, this is O, MgBr. If we'll do the hydrolysis of this, OH will be created here. Hence, we are expected to get the phenyl ethanol. So this is 1, 2, 1 at OH and 2 at phenyl. So 2 phenyl ethanol. So our option is B. Question number 7 is CO plus H2 plus H2. This is used for the manufacture of, this is a water gas, and water gas in industry is used for the manufacture of methanol. Which one of the following will yield 2-propanol? We have to find. If I'll do the hydrolysis of this, according to the Markovnikov's rule, the OH will go to the carbon having less number of hydrogen atoms. So that's why I'm getting 2-propanol in this reaction. If I'll do the Grignard reagent with the acetaldehyde, this will be CH3, carbon will get the CH3, and we'll get a secondary alcohol because this is the acetaldehyde. So we are going to get secondary alcohol. So this is also giving us the methanol. This will create HCC2H5. We'll get a propanol, but we'll get the primary one. And the last one with the neutral KMnO4, we are expected to get again oxidized product. So we are expected to get the methanol and the ethanol. Sorry, oxidized. So it is formic acid and the acetic acid. So the option is 1 and 2. 1 and 2. Hence option is A for the question number 8. The reaction is this on reaction with HBr. Now Br is expected to go to this carbon as well as this carbon. But when the Br is going, the negative part of the reagent goes to the carbon having less number of hydrogen. But here we can see they are having both equal number of hydrogen. But the one, if it is attached to here, this will be more stabilized due to the nearby benzene ring. Hence we are expecting the product B. In the following reaction, if we do the acidic hydrolysis of this, acidic hydrolysis will remove OH from here and H from any of the carbon. If you are removing this, then we are expected to get two products here, one alkene like this, or we are expected to get the alkene like this. But according to the Sedgwick rule, the one alkene which is formed is more substituted, is a major product. Hence our option C is the major product in this reaction. The major product in the reaction, we have CH3O, and this is secondary, that is isopropyl group. This is with the HI. So it is cold HI we are considering. So if it will give the product, we have to always remember lower alkyl halide and higher alcohol is formed. So lower alkyl halide, that means methyl, and isopropyl alcohol will be formed as a major product. Mark the correct order of decreasing acidity strength of the following reaction. Always remember, in case of phenol, electron withdrawing group increases the acidic nature and electron donating group decreases the acidic nature. If I talk about the NO2, they are electron withdrawing group. And if I talk about the methoxy, they are electron donating group. So in case of the two, the one which is at the para position will have the more effect than compared to the ortho position, meta position. So 2 will have more acidic nature compared to 4. Then we'll have 1 which is having no effect of any substituent. But in case of methyl again, the 3 at the meta position will decrease it more compared to the 5th one. So this is the decreasing order. So we are expecting option B in this. ethyl ester. So ethyl ester is, that means 2 carbons should be there, any ethyl ester. If it is allowed to react with CH3 MgBr in excess, so this will be added across the carbonyl group. We are expected to get CH3C. This is OMgBr, CH3, and this is OR. So in the first step, when this this oxidation will take place, we are expected to get, this is OMgR, CH3C, double bond O, CH3. We are expected to get acetone. But if I treat this with CH3 MgBr more, there will be one more addition to the CH3, will give you tertiary alcohol. Hence our option is A. Paracresol. If you talk about the paracresol, it's having OH and CH3 at para position. This is on treatment with the chloroform and alkaline media like NaOH. This will give you the compound X. This is something, the introduction of aldehyde group. Since it's at lower temperature, the aldehyde group will be attached to the ortho to the OH group. This is further on treatment with HCN. HCN will be get added across this. So we'll get OH, C, OH, CN, H. Followed by the acidic hydrolysis. If you do the acidic hydrolysis of this, the cyanide will be converted into corresponding acid. So we'll be getting C, COOH, OH and H. So according to this, our option is option C. Let us discuss some of the MCQs related to the solid state. Question number 1 is, KF has NaCl type of structure. The age length of its unit cell has been found to be 537.6 picometer. The distance between the K plus and F minus in KF we have to find, and accordingly the option is given. Now KF has the NaCl type of structure, that means it is something like FCC structure. Then related to its age length and the distance between the K plus and F minus, that is the radius of K plus radius of F minus. So if we have a K plus ion and if we have a F minus ion, the distance between the two, that means the radius of K plus radius of F minus. We have FCC structure, so R of K plus R of F minus is equals to A by 2. A is given to us, that is 537.6 divided by 2. So that is 268.8 picometer. So our answer is option B. Question number 2 is, in which of the following structure cation has the maximum coordination number? So if let us talk about first option, Na2O. In Na2O the ratio is 2:1. So it is expected the oxide ions forms the structure, that is O2 minus forms the structure, or you can say the lattice, and Na plus will go or will occupy the tetrahedral voids. Since Na plus goes in the tetrahedral void, here the Na plus has the coordination number is equals to 4. Next option we have zinc blende. The ratio is 1:1. Here S2 minus ions that forms the lattice and Zn2 plus goes in the tetrahedral void. We have written the answer tetrahedral void just because the zinc size is very small, so it will prefer to go in a tetrahedral void. But though it is occupying the tetrahedral void, after that also the ratio is 1:1. That's indicate it occupies 50% of the tetrahedral void. So if it is 50% of tetrahedral void, then coordination number of this again has to be 4. In case of next option, CaF2, the ratio is 1:2. Here 1 is calcium, so Ca2 plus that will form the lattice, and the F minus ion go in tetrahedral voids. So if F minus goes in tetrahedral voids, the coordination number of F minus is 4. Therefore, according to the ratio, calcium has the coordination number 8. Here it has 4, here it has 4. And the last one, NaCl, which is 1:1. Cl minus forms the lattice, and the Na plus ions that goes in the octahedral void. So the coordination number of Na plus is equals to 6. But now the question is having maximum coordination number, which we have got it for the calcium. Hence our option is option C, calcium fluoride. Question number 3 is, in the corundum, oxide ions are arranged in HCP arrangement and the aluminium ions occupy 2/3 of the octahedral volts. What is the formula? And the options are given. So if the arrangement is formed by the oxide ions, then aluminium Al3 plus ions occupying the 2/3 of octahedral void. So if I talk about O2 minus, there will be one octahedral void per atom of the O2 minus. So Al3 plus occupies 2/3 of this octahedral void, so that is equals to 2 by 3. So Al3 plus is to O2 minus, this is 2 by 3 per atom of oxygen. So that is 2 is to 3, hence formula is Al2O3. Therefore our option is option B. Question number 4 is, the unit cell of the binary alloy composed of the A and the B metals has a CCP structure with the A atoms occupies the corner. So A is at the corner and we have total 8 corners. B occupies the face center position and we have total 6 face center position. If during crystallization of this alloy, the unit cell, 2 A atoms are missing. So A out of 8, now 6 are left. So overall composition per unit cell. If the 6 are left, corners 1/8 portion goes into the unit cell. So this will be 3 by 4. So A will be 3 by 4 and B as it is 6 into half, that is 3. So A is to B ratio is 3 by 4 is to 3, that is 1 is to 4. So formula is AB4. So our option is option C. Question number 5 is, the fraction of the total volume occupied by the atoms present in a simple cube is. Now if you talk about in case of SCC, the number of atoms per unit cell is equals to 1. And therefore the volume occupied, considering that the shape of the atom is a sphere and the r is the radius, then it is 4 by 3 pi r cube. In case of the total volume for this SCC, that's equals to A cube. But for SCC, A is equals to 2r. So if we'll substitute this is 2r cube, so that will be 8r cube. So if I have to calculate the fraction of the total volume occupied, that will be 4 by 3 pi r cube. That's volume occupied divided by total volume, 8r cube. R cube cancel here. So answer is pi by 6. Option D. Question number 6 is, an element E crystallizes in FCC structure which is having cell H, that is A, is equals to 200 picometer. They have given us the mass which is containing 24 into 10 raised to 23 atoms. We have to calculate the density of this crystal. Density is equals to Zm upon Na into A cube. Now here Z, since it is FCC structure, it has to be 4. Let us assume the mass is 200, which is given, upon the number of atoms. Instead of writing the Avogadro's number, since they have given 200 contains these atoms, I am writing this 24 into 10 raised to 23 into, now this is age length is 200 picometer, which is 2 into 10 raised to minus 8 centimeter. So this is 2 into 10 raised to minus 8 centimeter cube. So this is 4 into 200 divided by 24 into 10 raised to minus, 23 into 8 into 10 raised to minus 24. So if you calculate this, finally this is 10 raised to minus 1. So 2000 divided by 24. So this will be 1000 divided by 24. So that comes out to be 4 41.6 gram per centimeter cube. So our option is option B. Question number 7 is, in which of the following crystals the alternate tetrahedral voids are occupied? So in this case we have answer Z and S. Here the ratio is 1:1. Sulfide ions form this structure. Zinc goes in tetrahedral void because of its smaller size, but though it goes in tetrahedral void, we have still the ratio 1:1. That indicates only 50% of tetrahedral voids are occupied. So our option is option B. In most, we have to find the unsymmetrical and the symmetrical respectively. When we talk about the Brevis lattices, the most unsymmetrical one is a triclinic, where all sides are unequal and all angles, that's alpha is equals to beta is equals to gamma, that is even not equals to 90 degree, they are all unequal. So this is about the triclinic. And the most symmetrical, we have two. One is a cubic, that is A is equals to B is equals to C, and alpha is equals to beta is equals to gamma is equals to 90 degree. And we also have the rhombohedral. In case of rhombohedral, we have A is equals to B is equals to C, alpha is equals to beta is equals to gamma, but that's not equals to 90 degree. So in the combination, we have option B, which is a combination of triclinic and the cubic. Question number 9 is, which one of the following compound exhibits both the Schottky as well as the Frenkel defect? So this particular defect is shown by AGBR, where the Schottky defect and the Frenkel defect both are observed. Question number 10 is, which of the following statement is not true about the hexagonal close packing? Here the coordination number is 12. When we talk about the hexagonal close packing, there are 6 atoms at the corner top of the hexagon. Similarly, you will find 6 at the down. So it's kind of like hexagon. There are 2 edge centers like this, and there are 3 body centers. So if you talk about this particular HCP, for the corner atom, now there are 6 and 6. There are 12 corner atoms, and each 12 corner atoms shares 1/6. So that will be 6 atoms in the unit cell. There are 2 atoms in the unit cell. Then there are 2 edge centers. Each edge center shares half for the unit cell, so that is 1. And 3 are the body centers, so they will contribute total. So there are total 6 atoms in this particular HCP, and they have the coordination number 12. So option A is right. Since they have coordination number 12, it's similar like FCC, and FCC has a packing efficiency of 74%. Therefore, HCP also should have the 74% packing efficiency. So even option B is right. Option C, the tetrahedral voids of the second layer are covered by the spheres of the third layer. Since this packing is AB-AB packing, we say the tetrahedral voids of the third layer covers the tetrahedral voids of the third layer. So it is right. In this arrangement, the spheres of fourth layer are exactly aligned with those of first layer. This is the wrong statement, because the spheres of the third layer are similar to the first layer, because this is AB-AB structure. Fourth layer becomes equal when we have ABC-ABC, where fourth layer becomes similar to the first layer. Hence our answer is option D. Question number 11. In the cubic cell, 7 out of the 8 corners are occupied by atom A. So A, 7 corners are occupied. Out of that, 8th portion will come in the unit cell. B occupies the centers of the faces. So 6 into half, that equals to 3. So general formula of the compound we need to find. So A is to B is 7/8 is to 3. So 7 is to 24. So A7, B24. So answer is C. Question number 12 is, in a spinel structure, the O2 minus R cubic closed packed, whereas 1/8 of the tetrahedral holes are occupied by A2. So A2 plus ions are occupying the 1/8. There are always two tetrahedral voids compared to one O2 minus ion. So A2 plus are occupying the 1/8 of the tetrahedral voids. So that will be 1 by 4. While 1/2 of the octahedral holes are being occupied by the cation B3 plus. So B3 plus is occupying half of the octahedral, so that is half. So A is to B is to O. A is 1 by 4, B is 1 by 2 compared to 1 atom of O. So this is 1 is to 2 is to 4. I have multiplied the entire equation by 4. So formula is A B2 O4. So answer is B. Question number 13 is the picnometer density of the sodium chloride crystal is 2.165 into 10 raised to 13 kg per meter cube, while its X-ray density is 2.178 into 10 raised to 3 kg per meter cube. The fraction of the unoccupied sites in the sodium chloride crystal we need to find. When we talk about the picnometer density, it is something, a density of the crystal which is calculated a complete crystal without considering or without removing the void spaces. But when we actually see the X-ray, we see there are some void spaces and there is some occupied space. So X-ray density is always it's something which is calculated by removing the empty space. The exact occupied density is the X-ray density. So if I have to find a fraction which is unoccupied, now this is the formula of density they have given. So density is nothing but the mass upon volume. But we need to find a fraction of the unoccupied side, so we are interested in volume. So volume is equal to mass upon density. So if I have to calculate the volume or a fraction of unoccupied sites, then fraction of unoccupied sites is nothing but the volume which is total minus the volume which is occupied divided by the total volume. Now which is total volume? I just said total volume is something which we calculate from the picnometer density. So from the picnometer density we will get to the total volume, and from the X-ray density we will get the occupied volume. You will always find the densities are reverse than the volume. So you will find X-ray density is more than the picnometer. So we'll do this. This is 2.178 into 10 raised to 3 minus 2.165 into 10 raised to 3. So when I subtract this, I'm just calculating the unoccupied sites divided by 2.178 into 10 raised to 3. This is 310.0 into 10 raised to 3 divided by 2.178 into 10 raised to 3. So if I calculate, if I tentatively consider this as 2 and this as a 13, so this should be 1, 2, 3. So this should be around 6 point something into 10 raised to minus 3. Now the answer which is most nearby is 5.96 into 10 raised to minus 3. So answer is option D. Question number 14 is the peroxide, a mineral of the titanium, is found to contain the calcium atoms at the corner. So calcium is at the corner, so 8 into 1 by 8, that's equals to 1. Oxygen is having face center, so oxygen is 6 into half, that's equals to 3. And titanium is at the center of the cube, so Ti will be 1. So if I check the formula, this is CaTiO3. Now here if I do the total of the oxidation number, calcium is always plus 2. We don't know about the titanium, that we have to find, so let us assume it as X. Oxygen is minus 2 into 3, that is minus 6 is equals to 0. So X minus 4 is equals to 0. So X is equals to plus 4. So answer is option D. Question number 15 is the KCl crystallizes in the same type of the lattice as does the NaCl. Given that R of Na plus upon R of Cl minus is equals to 0.55 and R of K plus upon R of Cl minus is equals to 0.74. Then we have to calculate the ratio of the side of the unit cell of KCl to that of NaCl. So ratio of side of unit of KCl, that means we have to find age length of KCl upon age length of NaCl. Now KCl and NaCl, both of them have the same structure, that is FCC, and for FCC we have a ratio that is r plus r minus is equals to a by 2. So that is nothing but a is equals to twice into r plus r minus. So this is 2 into r of k plus r of cl minus divided by 2 into r of na plus into r of cl minus. Now here 2 gets cancelled. I have here the value of r of k plus upon r of cl minus. I am making it r of k plus is equals to 0.74 into r of cl minus. So I am writing here instead of this 0.74 into r of cl minus plus r of cl minus divided by, similarly I am just substituting for r of na plus, that is 0.55 into r of cl minus. I am taking r of cl minus common from this. So it will be 0.74 plus 1. This is r of cl minus 0.55 plus 1. This gets cancelled. So this is 1.74 upon 1.55. That comes out to be 1.123. So answer is option A. Let us solve some MCQs on solution and colligative property. Question number 1 is 3 bottles A, B and C contains 1 molar, 1 molal and 1 normal aqueous solution of the sulfuric acid respectively. Which of the following statement is correct? A is less concentrated than B but more concentrated than C. A is more concentrated than B but less than C. A is more concentrated than B and C solutions. Concentration of A and C is equal but are more concentrated than B. So if we have 3 bottles A, B and C, A is 1 molar, 1 molal and 1 normal. Molarity is always greater than the molality and normality. So A is more concentrated than B and C solution. So our answer is option A, option C. Question number 2, which of the following solution pair can be separated into its pure components by the fractional distillation? Fractional distillation is only possible if the 2 components have the boiling point difference between them more than 30 degrees Celsius or 30 or more than 30 degrees Celsius. Now in case of water, we have 100 and this is around 78. It is just difference of 22 degrees Celsius. Water and hydrochloric acid. Hydrochloric acid is an aqueous solution only. So there is no much difference in the boiling point of the water and hydrochloric acid. Hexane is around 68 and heptane is around 98. So we have here a difference of 30 degrees Celsius. Acetone is 56 and this is 78. So this comes out to be around 2 and this comes out to be 22. So if I talk about the more difference is option C, where we have a large difference which the 2 solutions can be separated by means of fractional distillation. What volume of 36 normal and 1 normal sulfuric acid must be mixed to 1 liter of 6 normal sulfuric acid? Now we have to make the total volume as 1 liter. So we have a formula NTVT, that is total normality into total volume, is equals to N1V1 plus N2V2. Now the total normality we have got it 6 and the total volume is 1 liter. So I'm writing it as 1. The normality of first solution is 36. Let us assume we have taken X liter of this plus this is normality of second is 1 into this should be 1 liter minus X. So this should be 6 is equals to 36x plus 1 minus x. So this 1 that will come on that side, 5 is equals to 35x. So x is equals to 1 by 7 liter. So that's 1000 divided by 7. So that comes out to be 142.8 ml. So the first solution should be 142.8. So our answer is option B. Question number 4 is the molarity of pure water we have to find. Let us say we have taken 1 mole of water. So 1 mole of water, that is nothing but the number of moles, that is 1000 gram of the water we have taken. Now molarity is nothing but the mass which we have taken, 1000 upon molecular weight, that is number of moles, into this we have taken 1 liter of water, that is around 1000 gram. So this is 1000 gram of water upon its molecular weight. So this is number of moles divided by volume. So volume is 1 liter. So this is 1000 upon 18. So answer comes out to be 55.6. So answer is option A. Question number 5 is an azeotropic solution of two liquids has boiling point lower than either of them. When azeotropic mixtures are there, either they will have a boiling point more than the individual or less. Why they can have a boiling point more? If they can create a intermolecular interaction after mixing A and B. If the intermolecular interaction is stronger after mixing, then that will be having boiling point more. But if after mixing the two solution, if the A and B has the weaker interaction, the boiling point will be less. So here they have asked the azeotropic solution having the less boiling point. So it is possible only when they have a weaker intermolecular force of attraction. Weaker intermolecular force of attraction, that means they are volatile in nature, and if they are volatile in nature, they will show positive deviation from the Raoult's law. So option C. Question number 6 is which of the following has aqueous solution has a freezing point most nearly which is equals to the equimolar solution of K4FeCN6. If we talk about K4FeCN6, and we have to assume that complete ionization will occur. So this is a coordinate compound. When this will dissociate, we'll get 4 K plus ions and 1 FeCN6 ion. So we are getting total 5 ions over here. So 1 which can give us the 5 ions will be the answer. Here 2K2 and SO4, so that comes to be 3. Sucrose will not dissociate at all. This will 2 aluminium and 3 sulfate, that will make 5. And this is 3 potassium and 1, so that will make 4. So we want 5 ions, so option is C. Question number 7 is the normality of 1 molar H3PO4 we have to find. The normality is equals to molarity into the basicity of that acid. Here the molarity is given is 1 and the basicity, there are 3 H plus contributing. So 3, that's equals to 3 normal solution. Hence our answer is option B. Question number 8 is phenol associates in the benzene to form a dimer C6H5OH twice. So we know that twice of C6H5OH phenol will associate to give C6H5OH a dimer. So if I consider the initial condition over here, so 1 will dissociate to 0, associate to 0. But under final condition, if out of 1, X will undergo association, I will get these molecules X by 2. The normal mass and the observed molar mass of the phenol in the benzene are given 94 and 146.3. We have to find the degree of association. Now from here, we have to understand, if I have to calculate the total moles will be 1 minus X plus X by 2. So that comes out to be 1 minus this is 1 minus X by 2. Then this is nothing but when we talk about the normal molar mass upon the observed molar mass. So this is normal molar mass upon observed molar mass, normal moles upon observed moles. This is nothing but we can also calculate the normal moles upon observed moles. So normal moles which are found to be 1 minus X by 2 divided by observed moles are just 1. That's equals to normal mass which is given is 94 upon this is 146.3. So this is 1 minus X by 2 is equals to 94 upon 146.3. When you will calculate the X value, that comes out to be 0.715. So that is 71.5%. So our answer is option D. Question number 9 is a solution has 1:4 mole ratio of pentane to hexane. The vapor pressure of pure hydrocarbon at 20 degrees Celsius are 440 mm of mercury for pentane and 120 mm of mercury for hexane. The mole fraction of pentane in vapor pressure, that is it should be vapor phase. In vapor phase we have to calculate. Now when I talk about the pressure of pentane, let's say pressure of pentane which is given is 440 mm, and the vapor pressure of hexane which is given is 120 mm. Now when I calculate the mole fraction of pentane, the ratio is 1:4. So pentane is 1. So 1 upon 1 plus 4. So that's 1 upon 5. So it's 0.2. And the mole fraction of hexane, it's now this is ratio is 4. So 4 upon 1 plus 4. So 4 upon 5, that is 0.8. So when we calculate the pressure of pentane, total pressure of pentane in that solution, so that will be in the vapor phase, it will be mole fraction of the pentane into the pure pressure of the pentane. This is for the vapor pressure. So this comes out to be 0.2 into 440. So that is 88. Similarly, pressure of hexane under vapor phase. So it's mole fraction of hexane into the pure vapor pressure of hexane. So this is 0.8 into 120, that comes out to be 96. So the total pressure is 88 plus 96, it is 184. So if I have to calculate the pressure of the pentane in the vapor phase, the pressure of pentane is 88 upon 184. So that comes out to be 0.478. So answer is option D. Question number 10 is 0.002 molar aqueous solution of ionic compound CONH3 4 times NO2 twice Cl freezes at minus 0.00732 degrees Celsius. Number of moles of ions which 1 mole of ionic compound will produce on being dissociation. Now this is a compound given, but we don't know exactly which ions are present outside the coordination sphere. So we need to calculate from the delta TF, that's a freezing point difference. Now delta TF is equals to the freezing point of the pure substance minus the freezing point of the solution. Now here pure substance is 0 and the solution is given minus 0.00732. So this is 0.00732. But delta TF is equals to I into KF into molality. So this is 0.00732. I we have to calculate. KF is given is 1.86 into molality 0.0020. So I is equals to 0.00732 divided by 1.86 into 0.0020, and this answer comes out to be 2, because it's something like it is twice of this particular answer. If you multiply this, it's almost twice. So answer is D. Question number 11 is a 300 Kelvin of vapor pressure. At 300 Kelvin, the vapor pressure of ideal solution containing 1 mole of liquid A and 2 moles of liquid B is 500 mm of mercury. So when you take 1 mole of A and 2 moles of B, the vapor pressure found to be, total vapor pressure was found to be 500. Vapor pressure of the solution increased by 25 mm of mercury. So now this is P1 and this is P2. P2 is becoming 525. If the number of 1 more mole of B is added, 1 more mole of B is added, that means NB is now becoming, it's 3. Na is as it is, that is Na is equals to 1. So then vapor pressure of A in its pure state we have to calculate. Now according to the Raoult's law, pressure is equals to PA0 into XA plus PB0 into XB. Under first condition, we have 500 is equals to Pa0. The mole fraction is 1 upon 3. So it's 1 by 3 plus this is Pb0. This will be 2 upon 3. We'll multiply entire equation by 3. So it will be 1500 is equals to Pa0 plus twice of Pb0. Let's assume this equation number 1. Now under second condition, we have this 525 is equals to Pa0, that's XA. XA here is 1 by 4 this time, plus this is Pb0, this time it is 3 by 4. Multiplying the entire equation by 4, we'll get the answer 2100 is equals to Pa0 plus 3 Pb0. Let us subtract equation 1 from 2. So this is 3 minus, so Pb0, PA cancel, this is 600. If you substitute here, this is 1500 is equals to Pa0 we have to calculate. So 2 into 600, this is 1200. So 1500 minus 1200, so Pa0 is equals to 300. So answer is option A. Question number 12 is 1% solution of KCl, NaCl, BaCl2 and urea have their osmotic pressure at the same temperature in the ascending order we have to find. Now when I'm talking about 1% solution of, if I take KCl, now we have just calculating the osmotic pressure. Osmotic pressure pi is equals to ICRT for the electrolyte solutions. But here we are just having the information about the I divided by C is concentration, that is number of moles. Number of moles is inversely proportional to the molar mass. So pi is directly proportional to I upon M. So by KCl, it's 2 upon KCl mass is given, it's 74.5. So that comes out to be 0.027. Next is NaCl. NaCl will dissociate into 2 ions. NaCl mass is given is 58.5. So that comes out to be 0.0343. This is 1. This is 2. Now next is BaCl2 that will dissociate into 3 ions. BaCl2 mass given is 208.4. So that is 0.0144. This is third one. And finally we have the urea. Urea will not dissociate. So 1 upon 60. So that comes out to be 0.0167. So this is fourth. So in all this, the lowest one is the third one. Then we have fourth one. Then first and then second. So we have the option number D. Question number 13 is in 0.2 molar solution of the weak acid HX. The degree of dissociation is 0.3. Taking care for the water as 1.85, the freezing point of a solution we have to find. Now when HX will dissociate, we'll get H plus and X minus. Under initial condition, we have one of this, no dissociation. But under final condition, out of 1, 0.3 will dissociate to give 0.3 of H plus and 0.3 of X minus. So the total moles, if we have to find, so it's 1 minus 0.3 plus 0.3 plus 0.3. So this comes out to be 1.3. So here I is equals to 1.3 upon 1. So it's 1.3. Delta TF is equals to Kf into I into molality. Now Kf is given 1.85. I we have calculated it's 1.3 and it's 2.2 molar solution. So we'll get the answer 0.481. But the delta TF is equals to the pure solvent minus the solution. Pure solvent is 0 minus solution. This is 0.481 and this is TF solution. So TF of the solution is minus 0.481 degrees Celsius. So the answer is nearby option D. Question number 14 is the solubility of the gas in water at 300 Kelvin under pressure 100 atmosphere is given. So let's say S is equals to 4 into 10 raised to minus 3 when the pressure is 100 atmosphere. Therefore, mass of the gas in kg dissolved in 250 ml of water under pressure of 250 atmosphere. Now let's assume this is P1, let us assume this is P2. P2 is 250 atmosphere. We have to first calculate the S2 for this. So S is equals to K into P, that is S is directly proportional to P. So S2 upon S1 is equals to P2 upon P1. So S2 is equals to 250 into S1 is 4 into 10 raised to minus 3 upon 100. So S2 comes out to be, after calculation, it's 10 raised to minus 2. That means 10 raised to minus 2 kg will dissolve in 1000 ml of water. But they have asked us about the 250. So 1000 ml contains 10 raised to minus 2. So 250 will contain 250 into 10 raised to minus 2 upon 1000. So this is 4. So it's 2.5 into 10 raised to minus 3. So answer is option A. Question number 15 is if the deviation, in the boiling point, elevation in the boiling point of the solution, non-volatile, non-electrolytic, non-associated solid in the solvent, Kb is given is Y. So delta Tb, we have formula Kb into molality. Now Kb is given is X and the elevation in boiling point is given Y. So we can say from this molality is equals to Y upon X. Then the depression and freezing point of the same concentrated solution would be. Now depression and freezing point delta Tf is equals to Kf into molality. Same, it's the same solution. The molality we can write same. It's Y into X and this is given Z. Kf is given Z. So it should be Zy upon X. So we have Zy upon X. So answer B. Let us discuss the MCQs of the electrochemistry. Question number 1 is a solution containing 1 mole per liter of each CuNO3 twice, AgNO3, Hg2NO3 twice, MgNO3 twice is being electrolyzed by using electrode potential in volt and the reduction potential of silver, mercury, copper and the Mg are given. With increasing voltage, the sequence of deposition of the metal, the cathode will be. Now in this case, if we have to talk about, the first is copper with the 2+ charge having a voltage of around 0.34. Then we have silver with the +1 charge with the value of 0.80. And we have mercury with the +2 charge, that is 0.79. And finally we have Mg2 plus with the voltage of -2.37. Now Mg2 plus, it's very difficult to deposit with the negative electrode potential. Now we have only 3 options left. In this case, if you find, the highest potential is for silver, then for mercury and then for copper. So in increasing order, deposition will occur for the silver, then mercury and then copper. Hence option is C. Question number 2 is for the cell reaction Zn solid, copper 2 plus 0.1 molar giving Zn2 plus, which is having concentration 0.01 molar, copper solid. If the E0 of standard EMF of that particular cell with respect to E, we have to compare. So we have E is equals to E0 minus 0.0592 upon N log to the base 10. Here the concentration of Zn2 plus ions divided by concentration of Cu2 plus ions. So this is E0 minus 0.0592. There are 2 electrons exchanged log of concentration of zinc is 0.01 upon this is 0.1. So this will come 1 by 10, which I can write E0 plus 0.0592 upon 2 log of 10. So I can see now E is something which is we are getting after adding something into E0. So definitely E is greater than E0. Hence our option is B. Question number 3 is which one of the following will increase the voltage of the cell? The voltage of cell will be increased for this reaction only if the reaction will go in forward direction. Increase in the size of silver electrode, this is product increase. Increase in concentration of Sn2 plus, this is again something related to product. Increase in concentration of Ag plus, yes, this will be the option because increase in concentration of Ag plus, that is increase in concentration of reactant, will proceed the reaction in the forward direction and hence voltage will increase. Question number 4, which of the following solution will have the highest equivalent conductance? Equivalent conductance is nothing but is inversely proportional to the concentration. So lower is the concentration, higher is the equivalent conductance. So the lowest concentration we can see is 0.005. So that's our option C, will have the highest equivalent conductance. The coulomb of electricity required for the reduction of 1 mole of MnO4 minus to Mn2 plus. So if we are reducing MnO4 minus to Mn2 plus, here Mn is having plus 7 oxidation state which is reducing to plus 2. So there will be around 5 electrons exchange. So 1 Faraday of electricity is 1 mole of electron, that is 96,500 into 5. That comes out to be 4.825 into 10 raised to 5. So answer is option C. Question number 6 is the molar conductance of AB and AC electrolytes are given. If the ionic molar conductance of C is 120, then we have to find the ionic molar conductance of B. Now when I talk about molar conductance of AB, molar conductance of AB is nothing but the contribution of A plus and contribution of B minus. Now this is given is 120. But here they have given the ionic molar concentration of C. So this is molar concentration of A plus and B minus. I am writing this as equation number 1. Similarly, the molar conductance of AC is equals to the contribution of A plus and concentration of C minus. So here AC is given as 160, A plus we are not aware of, but C is given 120. So from this we can calculate for the A plus 160 minus 120, that is 40. If we substitute this in equation 1, this is 40. So 120 minus 40, that is 80. So for B, the answer is 80, option C. If the molar conductance C for NH4OH is given, its degree of dissociation we have to calculate. Alpha is always the molar conductance at C divided by its zero conductance, zero molar conductance at zero concentration. This is given to us, that is 11.5, but the molar conductance at zero concentration is nothing but the contribution by the individual ions. So this is 73.4 plus 197.6. So this is 11.5 divided by, if you make the total of this, it's 271. So this is 0.0424. So option is B. Question number 8 is which of the following shows the correct variation in the molar conductance versus C for acetic acid. Now when we talk about the molar conductance, it always increases with decrease in concentration. So if the concentration, in the other way we can say, if this concentration is increasing, this molar conductance is expected to decrease. Now we can see the decrease is option A and C. But this is for the weak acid, and that for weak acid there is always a variation, not a straight line like option C. Therefore option A, since this is asked for the weak acid. If it is asked for the strong acid, then we can go for option C. Question number 9 is 4.5 gram of aluminium, atomic mass it's 27, is deposited at the cathode at Al3 plus solution contained with this by the certain quantity of electric charge. The volume of hydrogen which is produced at STP from the H plus ion. Now we have to remember that a number of gram equivalents of that of H plus will be equals to the number of gram equivalents of that of Al3 plus. This is according to the Faraday's second law, because the same electricity is passed through the two circuits. Now gram equivalence of Al3 plus, if you have to calculate, the amount of substance which is deposited is 4.5. Atomic mass of aluminium is 27, that is divided by 3, which is charge on the aluminium, so that is equals to 9 gram is the equivalent weight of the aluminium. So if we calculate this, we get the answer, that is 0.5. So we are getting the 0.5 gram equivalence of the H plus to be deposited. If we talk about number of moles of H plus, then number of gram equivalents and number of moles of H plus are same, that is 0.5. If I talk about 1 mole of H hydrogen gas, it's 22.4 liter. So 0.5 is nothing but the half of that, it's 11.2 liter. But this is for H2. We have here H plus, so it will be around still half of this. So it should be 5.6 of liter of the H plus, because we are having the H2 here. So H2 and H plus, so mass difference is exactly half. So 11.2 instead of 11.2 liter, we'll get deposition of 5.6 liter. Question number 10 is, using the given data below, we have to, the equivalent potentials are given. The order of reducing parts we have to find out. In case of reducing parts, if we talk about, the highest potential is of 1.51, will be having the highest reduction power. So highest will be Mn2 plus, followed by 1.36, which is Cl minus, followed by chromium 3 plus, which is 1.33, and then 0.74, that is for chromium. So Mn2 plus, Cl minus, Cr3 plus and Cr, and hence our option is option B. Question number 11 is, consider the following 4 electrodes, PQRS, with a different concentration of copper 2 plus ions are given. If the standard reduction potentials of Cu2 plus Cu is 0.34, the reduction potentials in voltage of above electrode will follow the order. Now in this case, we have a formula, E is equals to E0 minus 0.0592 upon N log to the base 10, 1 upon Mn concentration. Now here, as the concentration of Mn2 plus will decrease, the reduction potential will also decrease. Now here, if we can see, the lowest concentration is with the P, that will be having the lowest reduction potential, then S, then R, and the highest will be for Q. Hence our option is D. Question number 12 is, what products are expected in the disproportionation reaction of the hypochlorous acid? If you talk about hypochlorous acid, it's HClO. When it will dissociate, will give you HCl and HClO3, because this is plus 1, which will reduce to minus 1, and it will increase to plus, this is plus 5. So this is disproportionation reaction. This will be 4 thrice. So 3, this is twice. So we are getting product HCl and HClO3. So option C. Question number 13 is, the cell zinc in combination with copper having E0 cell 1.10 was allowed to be completely discharged. The relative concentration of Zn to copper 2 plus we have to find. So now we have formula that E0 minus NE0 cell, NFE0 cell is equals to minus 2.303 into RT log to the base 10 concentration of Zn2 plus upon concentration of C2 plus. Now this is N is 2 here, Faraday is 96,500 into E0 cell, which is given 1.10. That's equals to minus 2.303 into 8.314 into 298 log to the base Zn2 plus upon Cu2 plus. When you calculate this log to the Zn2 plus, upon Cu2 plus. This answer comes out to be 37.3. Taking antilog on both sides, this will come out to be 10 raised to 37.3. So our answer is option B. Let us discuss some of the MCQs related to the thermodynamics. Question number 1 is 10 kg of 4 different gases, chlorine, methane, oxygen and N2, expand isothermally and reversibly from 20 atmosphere to 10 atmosphere. The order of amount of work that will be done, we have to calculate. Now if we'll talk about the mass wise, the methane is having the lowest mass, then nitrogen, then oxygen and then chlorine. So number of moles, if we'll find, there will be exactly reverse than the above order. We have W, that is work done, is equals to minus delta nRT formula. That is W is directly proportional to N. So as the N will increase, the W will also increase. Therefore the reverse order is to be followed. That is methane has to be highest, then N2, then O2 and then Cl2. Therefore, our option is option D. Question number 2. For the reaction C3H8 gaseous state 5O2 giving thrice of CO2 plus 4H2O, at the constant temperature we have to find the value of delta H minus delta U. First of all, delta H is equals to delta U plus delta nRT. If we'll talk about this particular equation, let us first calculate about delta N. So number of gaseous state on the product side is 3 and the reactant side, that is 5 plus 1, so 6. This comes out to be minus 3 and therefore we have delta N is minus 3. Therefore delta H minus delta U will be equals to minus 3 RT. Therefore our answer is option C. The next question is, given bond energies for N triple bond N, H, NH bonds are 945, 436 and 391 kilojoule per mole respectively. Then the enthalpy of the reaction N2 plus 3H2 giving twice of NH3. Now when I'm talking about this reaction, there is N triple bond N reacts with thrice of H single bond H giving twice of N3 having 3 NH bonds. So if I have to calculate the enthalpy of the reaction, there should be delta H is equals to enthalpies of bond enthalpies of the reactant minus bond enthalpies of the product. Now in the reactant we have one N triple bond N bond. So this is 945 plus there are 3 HH bonds here. So 3 into 436. This is of reactant minus in the product side we have NH 6 bonds. So 6 into that is the product side, that is 391. So if you talk about this total 945 multiplied by plus 1308, this minus 2346. So this is 2253 minus 2346. So this is minus 93. Hence our option is option A. Next question is, the latent heat of vaporization of a liquid at 500 Kelvin and 1 atmospheric pressure is 10 kilocalories per mole. The change in internal energy of 2 mole of a liquid that we have to find. Now this is something, a liquid changing to the gaseous state. For this, the delta H, that is latent heat, they have given, that is 10 kilocalories per mole. Now, when we talk about the delta H calculation, delta H is equals to delta U plus delta nRT. Now, if I calculate delta nRT over here, delta U first of all, let us talk about. Delta U over here, the latent heat of energy is given to be 10 kilocalories per mole. So, for 1 mole, it is 10 kilocalories. Now, we have to calculate for 2 moles. So, for 2 moles, there will be 20 kilocalories. So 20 plus, now this is delta N, since we have to calculate for 2 moles. So delta N is 2 multiplied by this R. R has to be 2, which is given, into the temperature, which is given 500. So this is comes out to be 2000 calories, but this is 20 plus this is 2 kilocalories. But now in this case, this is vaporization state, and in vaporization state, this particular delta nRT, which is turning from liquid to gaseous state. So on product side, there is a gaseous state, so this has to be subtracted from the 20. So this will this comes out to be negative minus 2 kilocalories. So answer will be 18 kilocalories. Question number 5 is the heat of vaporization for water, ethanol and CS2 are given. The order of intermolecular forces in these liquids. Now we have to remember when the liquid turning to the vapors, the amount of energy which is required, that is heat of vaporization. The more is the amount of energy required, that is indicating the intermolecular forces are more. So here if you will check, the highest required, it is for water, that is 40.6. So water is having the highest intermolecular force of attraction. Then it is 38.6, that is for the ethanol, and the least is for the CS2. So water is highest, then ethanol, and then CS2. Hence our option is option A. If mean molar heat capacities for the calcium oxide, carbon dioxide and calcium carbonate are given over here, we have to calculate the delta Cp for the given reaction. Now here delta Cp for the given reaction is nothing but the Cp of the product minus the Cp of the reactant. Now in the product side, we have calcium oxide and carbon dioxide. So for calcium oxide, it is 51.4 plus 30.5 for the carbon dioxide minus the reactant, we have 110.4 for the calcium carbonate. So this is answer is minus 28.5, that is joule per Kelvin per mole. This, if I convert this into kilojoule, so this is to be minus 0.0285. So that is kilojoule. So answer is option B. Question number 7 is 1 gram of sample of NH4NO3 is decomposed in the bomb calorimeter. The temperature of the calorimeter increased to 1.62. The heat capacity of system is 1.23 kilojoule per gram per degree. What is the molar heat of the decomposition of the ammonium nitrate? Now here it is 1 gram only, it is decomposed. So the value which is given is for 1 gram only. The temperature rise is 6.12. Just multiply the heat capacity. This is per degree, but it is now increased by 6.12. So 1.23 multiplied by 6.12. So answer comes out to be minus 7.53 kilojoule per mole. So our answer is option A. Question number 8 is the enthalpy change for the two reactions are given below. We have to find the enthalpy change for the following reaction. Now for the following reaction, if you will find, this is having thrice of carbon, that is indicating we have to multiply the equation 2 by 3, while the first reaction has to be reversed because we want C2O3 on the reactant side. So in short, equation 1 has to be reversed plus equation 2 has to be multiplied by 3. So when I'll reverse the first equation, I'll get the delta H of this is 1130 plus 3 into the heat of the second reaction is minus 110. So this is 1130, that is minus 330, that comes out to be 800 kilojoule. So answer is option D. Question number 9 is the values of delta H and delta S for the 4 different reactions are given. On the basis of these values, predict the one of these will be spontaneous. Spontaneity of reaction is generally calculated using value of delta G, which is delta H minus T delta S. The reaction will be overall spontaneous if delta H is negative and delta S is positive. So now the one which is having delta H negative and delta S positive is reaction 4. Hence our option is option D. Question number 10 is the entropy values in Joule per Kelvin per mole for the hydrogen, chlorine and HCl are given. Then the entropy change for the reaction we have to calculate. Now for the reaction, delta S entropy is nothing but the twice of entropy of HCl minus we have to subtract for the reactants. So entropy for H2 plus entropy for the chlorine. Now this is twice into the entropy of the HCl, which is given to be 186.7 minus hydrogen is given 130.6 plus this is 223.0. So if you do this calculation, you will get the answer 19.8. So answer is option D. Let us discuss the MCQs which are based on the organic compounds containing nitrogen and aldehyde, ketone and carboxylic acids. Here the first question is an organic compound A which is having formula C2H3N on reduction gives the compound B. This compound B on treatment with HNO2, that is nitrous acid, is giving us ethyl alcohol. And warming with the chloroform and the alcoholic KOH, the compound B same, that is chloroform and alcoholic KOH, it is giving the offensive odor. So conformly the compound B has to be primary amine. This is because the primary amine on treatment with let's say primary amine, if we have this RNH2, this is on treatment with RNH2, definitely gives us the primary alcohol. So if we are getting ethyl alcohol, so the compound B has to be ethyl amine. Similarly, this is the carbylamine test where the chloroform on KOH treatment gives the formation of isocyanide, which is giving the offensive odor. So this compound is obtained from the reduction of the A by the reduction. Therefore, this has to be conformly the cyanide. So it has to be C2H, there are two carbons. So there will be CH3CN, triple bond N. So this is cyanide, hence our option is B. Organic compound which is P having molecular formula C6H4N2O2 is insoluble in both dilute and acidic acid and base solution. So definitely if it is insoluble in acidic as well as basic solution, this compound has to be neutral. Here we have COH group, so not possible. Here we have phenolic group, not possible. Here we have amine group. This is acidic, these two groups are acidic and this is basic in nature. So we have only one option, that is A. Also it's showing the dipole moment is 0. Conformly the two substituents should be at para position. So our option is A. Identify the X in the following series. Now if you talk about this particular amide, that is in short there is an aniline which is being protected by the acyl group. So there is NHCOCH3. If you do the nitration of this, definitely this nitration will go at para position, followed by the hydrolysis will generate this NH2 group back. So our option should be option B. Towards the electrophilic substitution, the most reactive species. The electrophilic substitution, that is orthopara direction, is only possible when that groups are electron donating groups. In this case, NO2, NHCO, CH3 and the salt, they are electron withdrawing group. Only one group we have, that is NH2, which is electron donating group. Hence our option A is more reactive towards the electrophilic substitution reaction. Next reaction we have, there is a cyanide at one position and there is OCH3. This is on treatment with the CH3 MgBr. Grignard reagent reaction always occurs with the cyanide. If you have the aromatic or aliphatic cyanide on reaction with Grignard reagent, that's going to give us the ketone followed by the hydrolysis. So here CH3 is there. So we are expecting the cyanide will turn to COCH3 without affecting the OCH3. Hence, our option is option B. Next question. Amongst the given set, the reactants the most appropriate for forming the secondary amine is. If you allow this to react with NH2, NH3, this will give us the Br substitution by NH3. So this will give us the secondary amine. Given set is not it. This will give us the secondary amine, but since ammonia is used, this may carry out the reaction further to give the tertiary and the quaternary also. B option is the treatment with NaCN, where the R cyanide will get followed by the hydrolysis will give us the formation of cyanide, that is CH2NH2. So that will give us the primary amine. If you talk about the third option, the RNH2 is on treatment with the aldehyde. Aldehyde will give us the reaction where there will be aldehyde formation, oxime formation over here. So R, there will be NH, double bond CH, R, followed by the reduction. Reduction will give us this R, CH2, NH2, CH2R. Still, if you talk NH, so this will become NH, CH2R. So there will be secondary amine formation in this case. And finally, RBr on treatment with potassium thiocyanide. This is giving us the formation of primary amine. So our option is option C. Next question. In the following reaction sequence, predict the compound X and Y in this case. If you allow this to react with the bromine, excess of bromine, there will be substitution at the ortho position. So we should get the substitution at ortho position. So we are having option A is there, B is also there, C is also there. So A, B, C. But followed by the NaNO2 and HCl, followed by the H3PO3. So this will create a diazonium salt here, followed by the H3PO3. So that will remove the entire diazonium salt. So 2 bromine and CH3 will be left. Hence our option is B. In the reaction aniline, a colored product C, which is formed. If you treat this with the diazonium salt, will get the diazonium salt in this case, followed by its reaction with this compound will create the double bond at para position like this. This will be colored complex which will be formed in the reaction. Hence, if you find according to this, the option is C. Next is the correct order of increasing basic nature for the amine. There is ammonia, CH3NH2, that's a primary amine, and CH3 twice NH. In this case, the secondary amine is more reactive than primary and then ammonia. So in this, according to this order, the option D is the correct answer for this. Toluene, that is CH3 on the benzene ring, is nitrated. When it is nitrated, the resulting product, nitration, will give us two products, CH3NO2 plus CH3NO2, which is having at the para position. And this is reduced. So when it is reduced, this will give you corresponding amines. So we'll get CH3 aniline like this, orthoaniline, and the para-aniline like this. This is for the... Next question is the toluene is nitrated and the resulting product is reduced with the teen and the hydrochloric acid. In case of toluene, we have a methyl group which is ortho and para directing group. So the nitration will take place at ortho and the para. Next, it is when it is reduced with the teen and HCl, the NO2 group will be reduced to corresponding NH2. Then further they are saying the product so formed is diazotized. So diazotization with NaNO2 and dilute HCl that is nitrous acid, will give us the diazotization at ortho and para position, and which is finally heated with the cuprous bromide, which will give us the replacement of the diazo group with a corresponding bromide. So we are expected to get ortho and para bromotoluene. Hence our option is option B. What is the product obtained in the following reaction? Here we have a nitrobenzene which is being reduced with a zinc, but not in HCl condition. We are having a neutral condition of ammonium chloride. Hence we are going to get the partial reduction to get NaOH. Our option is option A. Next question is, the toluene